Hi, today we're going to learn about the implicit differentiation. This topic does not have a specific formula. We're going to start off with an easy example. Prove that x squared plus x times y equals 10 is dy over dx equals negative 2x minus y divided by x. We're going to prove that this original formula, the derivative of it would be this one. So start off, first we have to derive the whole equation. Deriving 2x squared would give you 2x, because the exponent, you bring it to the front, you multiply it times the front number, in which this case is 1, and then you will subtract it by 1, giving you this 2x, plus you put brackets because the x times y is multiplication, and when you're deriving a multiplication you have to use the product rule. So you put x times y prime plus y times x prime equals, the derivative of a constant number would always equal 0. So what you do next is that you simplify it. So it would be 2x plus x. The derivative of y would be dy over dx plus y times 1. The reason for why the x is 1 is because it's dx over dx. In other words, it could equal 1. So you close the bracket, equals 0. You continue simplifying it, so it would be 2x plus x dy over dx plus y equals 0. You want the dy and dx by itself, so you can subtract the 2 and the y. Whatever you do to one side, you do it to the other side. So you subtract 2x minus y. This cancels out. You're left with x times dy over dx equals negative 2x minus y. Ooh, you're trying to get the dy and dx by itself, so you divide the x. Whatever you do to one side, you do to the other side, cancels it out. It leaves the dy and dx by itself equals negative 2x minus y divided by x. This proves the answer correct. This is an example of an easy implicit differential equation. Okay, going into medium equation. Okay, x cubed plus 2 squared times y plus 2x plus 2 equals 27. Prove that dy over dx equals negative 3x squared minus 2xy divided by x squared plus 1. So you derive the equation, the original equation. So for the x cubed, you bring down the 3, you multiply it times the number in front of x, in which this case is 1, so it would be 3x squared plus, you put brackets because the x cubed times y is multiplication, so you use the product rule. So you put x squared parentheses y prime plus y times x squared prime, you close the brackets. The derivative of y would be dy over dx plus 2 plus any constant would be 0. 0 equals 0. So you simplify it. So it would be 3x squared plus brackets x squared times dy over dx plus y times the 2x, you close the bracket, plus dy over dx plus 2 equals 0. So again, you simplify it to get dy and dx by itself. So what you can do is 3x squared plus dy over dx times x squared plus 2xy plus dy over dx plus 2 equals 0. You can get rid of the 3x squared, you can get rid of the 2xy, and you can get rid of the 2. So whatever you do to one side, you do to the other. So it would be dy over dx squared plus dy over dx equals negative 3x squared minus 2xy minus 2. You have a common factor, which would be dy over dx. You factor it out, gives you x squared plus 1 equals negative 3x squared minus 2xy minus 2. Try to cancel the x squared minus plus 1, so you divide it. X cubed squared plus 1. Whatever you do to one side, you do to the other side. So it would be, cancels it out, dy over dx will equal negative 3x squared minus 2xy minus 2 divided by x squared plus 1. This would be a medium problem. Okay. Proving that the original equation would equal this. With each step you have to prove it, and the final answer proves it. Okay. Going into a little bit more challenging implicit differentiation would be this example. X cubed plus xy times plus y equals 17. X equals 2. Solve for dy over dx. Okay, you would have to derive the original equation. So you have x cubed. So you have to derive it, which would be 3x squared plus the brackets x y prime plus y times x prime, close the brackets, plus the derivative of dy over, the derivative of y would be dy over dx equals, every constant equals to 0 when derived, so it would be 0. So after that, you simplify it, which would be 3x squared plus x times dy over dx plus y cancel, when derived in x, it equals 1, plus dy over dx equals 0. Next, you can get rid of the x3, you can get rid of the 3x squared, you can get rid of the y. So whatever you do to one side, you do to the other side. This cancels, this cancels. So you're left with x times dy over dx plus dy over dx equals negative 3x squared minus y. You have a common factor here, which would be dy over dx, so you factor it out. So it would be dy over dx, parentheses, x plus 1 equals negative 3x squared minus 1. You divide it to cancel it out, so you can have the dy and dx by itself. So whatever you do to one side, you do to the other side. Cancels it out. Dy over dx equals negative 3x x squared minus y equals x plus 1. We're almost done. However, they gave us an x equals 2. So you go back and you plug the x to its original equation. So you'd have to go back. X cubed plus x times y plus y equals 70. For the 2 you plug in, for the x you plug in the 2. So it would be 2 cubed plus 2y plus y equals 17. Okay, x 2 cubed would be 2, 4, 8 plus 2y plus y equals 17. You get rid of the 8. You want the y to be by itself. So you use simple algebra. So it would be 3y equals 9 divided by 3 divided by 3, y equals 3. So you got the x and you got the y. You already solved the y, you solved the x. So just plug it in into the dy and dx to solve for the dy and dx. dy over dx equals negative 3 2 squared minus 3 over 2 plus 1, which would give you dy over dx, which would give you negative 3 times 4 minus 3 divided by 3. You would use simple adding and subtracting, which would give you negative 12 minus 3 equals negative 15. Negative 15 divided by 3. So dy over dx would equal negative 5. This is the final equation, final answer. So that is how you use implicit differentiation. That's how it applies in calculus. And thank you for joining us.